Hello lovely people. Condensation, hydrolysis. What does condensation mean? To form water. Mum's cooking in the kitchen, she's boiling some potatoes or whatever it is, the window is closed, you look at the window, steam on it. Condensation, formation of water. Opposite to condensation, hydrolysis. Hydro, water, lysis, to split, to break. Okay, hydrolysis condensation typically occurs between two molecules which have got hydroxyl groups. Or it could be a group that has the hydroxyl component. What is the hydroxyl group? The OH group. Now remember, the organic molecule has to bind to the oxygen, which in turn binds to the hydrogen. Why am I being so specific about this? Well, this is the reason. So if you look over here, I've got you a hydroxyl group. The oxygen binds to the molecule, and that in turn binds to the hydrogen. I could not write this the other way, so I couldn't write O here and H here, and then that binds to the molecule. That would be incorrect. Okay, the molecule binds to the O and in turn to the H. As I've shown here, this here is what we call the carboxyl group, typically found in acids. So the carbon binds to the oxygen, which in turn binds to the hydrogen. This is how it must be written. If you write this, for example, the other way around with the bond here, then that would be incorrect. You will not get the mark. That clarified. Hydrolysis, as I said to you, hydro means water, lysis means to split. If you look at lysosomes, zome means a vesicle, lys means to split. So a molecule which contains, or a vesicle which contains substances or enzymes which are going to digest. So they're going to hydrolyze. So typically these reactions are hydrolytic reactions. Here we have water splits into OH and H. Now the OH is typically OH negative or OH minus and H plus. That's a proton. Any solution that contains OH minus is an alkali. Any solution that contains H plus is an acid. We can look at that in acids and bases lecture. Very brief overview. So that is basically that. Now if you look at two monosaccharides, the monosaccharides, both of them have got a hydroxyl group. The two hydroxyl groups come together. And in doing so, what they'll do is they'll form a molecule of water. So here we are, except I've not drawn two hydroxyl groups here. All I've shown you is a hydroxyl group with a hydrogen to form H2O, which is the opposite to what I had over here. Okay, splitting, and then here we have the forming. Now if I had two hydroxyl groups over here, what would happen is this bit would leave, and then you would have the R group. This represents the organic molecule, as does this, a separate one. The R would still have an oxygen here, and that would bind to this R. So you'd have an ROR. And the R, like I say, is any organic molecule. So typically that would be a carbon, oxygen, carbon. And that is what we call an ester bond, so an acidification reaction. And so that is it. Hydrolysis and condensation. Two monosaccharides coming together, two hydroxyl groups coming together, condensation reaction to form a disaccharide. So glucose at glucose, maltose, glucose at fructose, sucrose, glucose at galactose, lactose. On the other hand, you go the other way, and it's a hydrolysis reaction. Why? Because you're going to split the water molecule and add it to this disaccharide, so that we can then form two monosaccharides, each with their own hydroxyl group. I hope that helps. Like it, share it, and any other videos you want me to do, short topics, don't hesitate. Thank you.